Hey guys, in this chapter review, we did this table, and you can do this on a piece of graph paper or really a piece of notebook paper. It really doesn't matter. We did what's called the blue foldable. That's this one on prisms and pyramids. And we did this square foldable on circular things. Okay, so I'm going to go over each one. Then also our homework was this topic review. So you'll see that in Canvas. And if you don't have this piece of paper, you want to stop by and get one, I made a copy for you. Or you can also just work the questions on another piece of paper. Okay, so let's go over what classwork we did to review for the test. As you can see here, we drew each shape. So you want to start out at the top here, right? Drawing each shape. And we have two P's, prism, pyramid, cylinder, cone, and sphere. We also have been writing multiple times over the chapter, the formula, the general formula, the volume is equal to the area of the base, big B, times the height. So in our example here, rectangular faces, prisms make rectangular faces around the outside. But prisms can actually be made by stacking squares, rectangles, or any polygons. So you'll see prisms, I think during the chapter we saw a hexagon prism, octagon prism, we could do a trapezoid prism. So the area of the base would depend on what polygon that is. And then you multiply by the height after you have the area of that base. So in our example, it's a rectangle, so that's why we just need the base and the width. All right, now pyramids, they're made by stacking shapes, excuse me, but notice how the shape is getting smaller and smaller until it turns into a single point. So because those shapes are getting smaller and smaller, it creates triangular faces. And we learned the volume would be equal to the base, the area of the base, whatever that is, times the height, but then divide by 3. So in this rectangular base, we'd need the base, the width, and the height, but we'd have to divide by 3. I put an X here because it cannot be made by stacking the same size shape. Okay, so cylinders are also made by stacking the same size shape, stacking circles of the same size. That's why its formula is the area of the base times the height. Since the base is a circle, that's why this is the formula for a circle. And then we multiply by our height. A cone. Well, a cone would not be made by stacking circles of the same size. Notice our circles are getting smaller and smaller and smaller until they turn into a single point. So that would mean the formula is the area of the base times the height divided by 3. So this is our area of the base, the circle. Then we multiply the height and divide by 3. So this is our more specific formula for our cone. Last, we have our sphere, and this formula is provided on the formula sheet, but there's no picture and no label. So you have to know that this goes with this object or this word, vocab word. Notice it is not made by stacking the same shape. In fact, it's made by stacking shapes that are getting circles that are getting larger and larger until they get to the great circle. And then the circles get smaller and smaller again until you get to the South Pole. So let's take a look at the next column. It says, made by stacking smaller, stacking things that get smaller. These stay the same size, so we're not going to pick prism. Here, pyramids are made by things that are getting smaller. So rectangles, squares, or any polygon that's getting smaller. As we showed, I could show a triangle, and the triangle is getting a little smaller and a little smaller and a little smaller. That would be my triangular pyramid. I could also have a pyramid of, some weird shape. Doesn't matter, whatever the polygon is. If that shape gets smaller and smaller and smaller, it's a pyramid. A cylinder is not made by stacking things getting smaller because it's made by stacking circles of the same size, like stacking up quarters. So our cone falls into this category, circles getting smaller. And we see that with my red pen. Our sphere is also one of these. As I mentioned, if you started at the North Pole and look at all these longitudinal lines, these circles would get bigger and bigger and bigger until they get to be the size of the Great Circle at the equator, and then they get smaller and smaller. So we could make a sphere by stacking circles that first get larger, then get smaller. Our last category goes all the way back to chapter 11:1. Which shapes are made by spinning? And so we notice that these don't have any circular faces, so these cannot be made by spinning. But we investigated with some classroom tools that a rectangle that's spun around and around and around would make a cylinder. A rectangle spun around and around, right? And a triangle, whether it's this full triangle on its altitude or it's already a right triangle on its altitude, triangles that are spun make cones. We can imagine this triangle inside of there spinning around and around, making a cone. Last, if I spin a semicircle, that would be half of a circle, or I spin a whole circle, either way, spinning a circle or semicircle would create this sphere in the air by spinning it around. So that is our table. Now, we have two more foldables that, let's just do now. We'll just do this. So foldable 1, prisms and pyramids. So question number 1, it says, what is the volume? And it's the area of the base times the height. So since the base is a rectangle, we just do 9 times base times width, or 9 times 5 times a height of 4. We get 180. Question number 2, it says the base is a rectangle, so 6 times 11 times however high we stacked it. Right? Question number 3, now we're stacking rectangles and we're stacking them into the page. So if we stack these rectangles into the page, that's how high we stack them horizontally, 14. So that's our height, 14. But notice our base is a triangle, so we have to find the area of this base, and since the front and back are the same size, we could transfer the 10 there, and we see the base is 10, and the altitude is 5. So we get the area of our base is a triangle, that's 1/2, 10 times 5 times 14 to get 350. Question number 4, we have a right triangle, and that's prism is made by stacking these triangles, a horizontal height of 9. So the area of this triangle would be base times width, or base times altitude divided by 2. Notice it would be a rectangle and then they cut it in half. So 1/2, 8 times 3 times the height of 9, and we get 108. Question number 5. Now we have our trapezoids. So you can make a prism by stacking trapezoids. Looks like we did. Stacked them and stacked them and stacked them. Vertical height of 7. So our vertical height is 7. And this is the formula for the trapezoid. So we have 2 bases here. The long base is 7. We can transfer this. The short base is 4. And they have an altitude of 2. So 1/2. Base 1 is 4. Base 2 is 7. And then we multiply by the altitude of 2 and the height of 7. So we get 1/2 times 11 times 14 is 77 centimeters cubed. Question number 6, another trapezoid, but it looks like they stacked it horizontally. So the horizontal height is 15. And we transfer the 7 to find the base. One base is 7, one base is 10. And we have an altitude of 4. And we multiply by the height of 15. So we get 1/2, 17 times 4 times 15, which is 510 centimeters cubed. 7. Now these shapes are getting smaller. These triangles are getting smaller and smaller, or rectangles. So we find the area of the base, which is a rectangle, 7 times 3, times however high we stacked it, 8. And then don't forget to divide by 3 because the shape got smaller. So we get 56 centimeters cubed. Going to number 8, we've got 5 by 4 by a height of 6. So 5 times 4 times 6, but we want to divide by 3, so we get 40 centimeters cubed. Question number 9, it says we have a triangle base, not a square base. And so this is made by stacking triangles, right? And those triangles are getting smaller. So the area of the base times the height divided by 3. But our base is a triangle. So the area formula of a triangle is 1/2 base times altitude. So 1/2 the base of 4 and the altitude of 6. So 1/2 4 times 6. And then we multiply by the height of 7 and divide by 3. Don't forget, it's getting smaller. So we get an answer, 84 for the numerator and 3 for the denominator, gives us 28 centimeters cubed. All right, question number 10. It's a triangle base again, so the same formula as question number 9. 1/2 base of 8, altitude of 10, and we stacked this 12 high. And then after all that, we're going to divide by 3. So 480 divided by 3, we get 160 centimeters cubed. Awesome. Okay, last foldable. And this one kind of spins around and around. So let's see. I'm going to spin this and start. Let's start with our circle. So the first one I want to talk about is my circle, and that one is, are you going to fall for that? It doesn't tell us the diameter is 10, but I want to prepare you that on the test, if they say the diameter is 10, notice there is no D in the area formula. So if the diameter is 10, you will then calculate that the radius is 5, and then you can plug in 5, okay? I also want to prepare you that the area formula is pi r squared for a circle. So we had pi times 5 times 5. And they might ask you to leave the answer in terms of pi. So we would leave the answer 25 pi. Here, though, they've asked us to multiply 25 by 3.14. And we get 78.5 inches squared, because this is a 2D calculation area. Okay, question number 2, find the volume. So the area or the volume of anything in the universe is the area of the base times however high you stacked it. So we stacked these circles 12 inches high. And our base is a circle, so that's why we're plugging in pi r squared h. We get pi times 5 times 5 times 12, which is 300 pi. Be prepared on the test to answer in terms of pi. But here, they've asked us to go ahead and multiply by 3.14, so we get 942 inches cubed because volume is a 3-dimensional measurement. Okay, now I'm just going to rotate my paper around. I've got, maybe I rotated it a little too far. Okay, we got question number 3, find the volume of a cone. So our cone is circles getting smaller. So we have pi r squared h divided by 3. So we have pi 5 times 5 times 12 divided by 3. Notice I didn't use the number 13. That's not how high I stacked the circles. I stacked the circles 12 high. So this slant height is actually a distractor. It could be useful in some problems, but it's not needed to find the volume. It might be useful to find like the surface area. So we notice when we multiply this through, 5 times 5 times 12 divided by 3 gives us 300 in the numerator and 3 in the denominator, so we get 100 pi. this is a third of the question we just got done doing that was 300 pies, so that makes sense. Now multiplying it out, 100 times 3.14 is 314 inches cubed. Question number 4. Again, I remind you to find the volume of a cylinder or a sphere. They might ask you to find it, but notice this formula doesn't have a D. So if they gave you the diameter was 10, you know the radius is 5, and you plug in 5 for the radius. So 4 times 5 times 5 times 5 is 500, and then you divide by 3 pi. They could also ask you to go ahead and divide 5 by 3, so that'd be 166.7 pi. Here they've asked us to go all the way and multiply that through, so 166.7 times 3.14 is 523.3 inches cubed. Now we don't have an example in our foldable, but I do want to mention they could also ask for a hemisphere. So a hemisphere, instead of being 4/3 pi r cubed, is 2/3 pi r cubed. Okay, last little bit. So you could put this back on your table, or you could put it, maybe on the back of your foldable somewhere. We do want something referencing how do these shapes relate to each other. So remember from class, in a couple of our formula discussion questions, we said 3 cones would fill a can or cylinder, right? That's why this formula is a third. We also noticed 2 cones filled a hemisphere. That's why 2/3 pi r cubed is the formula for a half of a sphere. Now, if we do a little bit of kindergarten substitution, we could substitute these there, but that's the same as that. So notice we've substituted this where the 2 cones were, and we should know that 1 scoop and 1 cone would fill a can. 1 hemisphere, 1 cone fills a cylinder. We can also see if 2 cones filled half of a sphere, that 4 cones should fill a whole sphere. And that, my friends, is the geometry chapter review from class.